I have the honor that I can announce Jan Seyler. May you know him as moderator before. Now he changed his role and give us a speech with a very nice title, Autonomous Agents, Many Little Helpers for Everyone. Thanks, Jan.
Thank you. Thank you so much. Yeah, changing roles, same position. Oh, even applause before. Yeah. Great moderation. Yes, so actually my talk is kind of a first talk of a two-talk, longer talk, let's say. So the talk right after me is Martin and Manuel, who will look more into detail and more in concrete examples of multi-agent systems. But what I will show is a very, very high-level abstract talk where this could lead us and what it means for basically everyone. And it's a bit hard to follow up to the talk that we just had. It was a great talk, but I will try my best to make it interactive and worthwhile your time. If it's not, then tell me afterwards and I will try to change how I present. Okay, so the title, Autonomous Agents, Many Little Helpers for Everyone. The question that you should ask yourself behind this is, what if you had a team of invisible assistants, each specialized in solving one tiny part of your day? Right? So you have a whole fleet of assistants and they can do exactly one thing. Maybe they can even communicate with each other and can somebody distributes tasks to them. And if that would be true, how much more could you achieve? So if you really just need to formulate your questions, if you need to formulate what you want to do, and then having this definition, a system of little helpers, supports you as good as possible, prepares everything for you, how much more could you achieve? And normally this is something exclusive for higher management, right? So executives and our board members, and they have a lot of assistants and they do a lot of things for them and they prepare a lot of things. But what if this is true for everyone, right? If everyone could have a lot of assistants to help them do their work. And this is what I want to dive into and also get a lot of your opinions on this. But first, I want to define what are autonomous agents. And yeah, these are not pixel errors, so these come in later. They are important, these little dots. But let's say, define it in a very simple way. Let's say an autonomous agent is a digital helper that can act independently. So this is the autonomous part. It can act independently, react to its environment, and by that, accomplish a task. If they work together, they could collectively perform very complex tasks. And what do I mean by working together? As I said, like, imagine all of these dots are little helpers, they are little agents. Actually, in this example, they are neurons, single neurons, but if they work together, they can do like a very complex task, like walking, standing upright, talking to each of you. So if you really have specialized agents and they can work together in an efficient way and somebody orchestrates it, then we can achieve great things. And this is what humans have been doing for the last centuries. But this is the first interactive part. You already know Menti from Karina's talk. So I will also use Menti. And the question is very general. It's a yes and no question to start easy, binary question. Do you think that systems of agents one day could mirror very complex thought processes, habits, and maybe even creativity? So just, there is no right or wrong answer. Just scan the QR code and give me your opinion. And I will move to this. And we will see the average and distribution of a binary question. That's interesting to have a distribution of a binary question. But you can say no is on the left-hand side, and I strongly agree on the right-hand side, and you can choose between 5 points, I think. So you can choose between, I'm very strong against it, I'm very for it. Okay, so some people are done, 26 answers, that's good. So that's good. I'm apparently speaking to people that are more positive about it. They think maybe we can get there. Could also be that people are really thinking this is all nonsense and I have to convince you. But apparently I don't have to, which is great, because then we jump in and have first a little look back to the last year. I don't know who of you were here last year. Last year I also had a talk about AI and how AI can transform our industry. And one example that I brought back then was how AI can solve tasks. So maybe you remember this very simple example of a task formulation. I referred, it was a master thesis in our department some years ago. And the task description for everyone who was not there is just these empty circles describe the goal state, and this is the beginning state. So the starting state is given by this, and the circles are the goal state, and you can perform very simple tasks. You can manipulate these balls by painting them in a color, by welding them together, and of course by moving them. So you can grasp them and move them. And what I have showed back then is that if you use classical planning, you can receive optimal machines. So the vocabulary that you get here is really components and how to use those components. So basically what Festo is doing, right? So a vocabulary of single components. And what I have shown back then is you actually not only get the optimal plan, the optimal task, but the optimal machine doing the task. So it's the planning plans the whole machine and how the machine acts. And I don't know how many of you would have come up with these solutions, but we tested it. They are optimal in sense of steps, right? So how many steps, work steps do they perform? And now maybe let's take another step, right? Let's move this very abstract task to the real world. The real world, and Martin will maybe talk about it later, looks a bit different. Maybe we have a workspace. So this gray area just shows a workspace, and we have some objects in this workspace. We have a pair of scissors. We have a band of tape, a roll of tape. We have a cloth, some fabric, and we have this wrench. And we don't only have this. I said it in the very beginning as an answer to one of the questions. If we want to actually interact with these objects, we don't just need balls and they turning blue, but we need a physical system, right? So let's add a physical system, a classical Festo gantry system on top of this. It's not, like the perspective is not ideal, but let's say this system reaches everything, right? So it can reach the whole workspace. And then the system needs tools to interact with its environment. Let's give it 3 tools. So we have a classical 3-point gripper, we have a parallel gripper, and we have a suction cup just to handle objects. It's not a very complex system, but if you just imagine this, you imagine having a physical system that sees its environment. Of course, it also needs some kind of camera. I didn't put the camera here, but you need some kind of camera. It sees its environment, and it can choose of a vocabulary of tools and then solve a task. Then, of course, you can do simple things, right? You can tell it, move to the tape, or move to the scissors, move to the wrench, and so on. But that's not very impressive. I mean, it's cool that it works, and so, but it's not that impressive, especially because you could have learned what a tape is, you could have learned what the scissors are, and then you just need an object detection. You need to transform the pixels of your image to coordinates in the real world, and then you move there. So not that great yet, but it would help, because today you have to program it. So it would already be one step to be easier to interact with the real world. But let's imagine further. I want to send this wrench out. So my task is I want to pack this wrench and send it out. And maybe I'm not very sophisticated in this, or I don't want to think about it. I want to pack it with the items that I have in my environment, right? The tools that are available and the items that are in my environment. And now I know it's still like after lunchtime and maybe you ate a cake, so we have to think a bit about it, but let's just think some seconds, how would you do that, right? You have a pair of scissors, you have the tape, you have a cloth, and you have the wrench. How would you pack this wrench to be ready to be sent out? I just wait. No, I don't want any answers. I don't want to put anyone on the spot, but I give you some time to think about it. Okay. So I'm sure everybody came up with some kind of solution, probably put the wrench into the cloth and then, I don't know, tape it or so. But the impressive part, and this is what I've tried out some time ago. I just asked it to ask this GPT 4.01, so the large reasoning model that OpenAI brought out. It's not a large language model, but they said it's a large reasoning model. And what is reasoning? Reasoning is exactly this type of, what do I have? How can I use it? Get to a conclusion with objects that you have in the real world. And this is the answer. So I didn't do anything. I didn't train anything. I didn't do anything. I just took the model as is out of box. And I told the model, this are the tools that you have. And I asked exactly this question. I want to pack the wrench to send it out. I didn't tell it to put it on the cloth. I didn't tell it to do anything. And what you actually see is that it does kind of logical steps, right? So first it puts the wrench on the cloth. I would not choose the 3-point gripper. I would probably choose the parallel gripper. But other than that, it's a pretty good plan. Then you wrap the cloth around the wrench. It even says how to fold the edges. So you take an edge and fold it over and take the second edge and so on. So it gives you a plan how to fold it. Then it tells you to secure the folds so it doesn't unravel immediately. And then it tells you to take the tape, right? Because it doesn't help if it's just wrapped in a piece of cloth that needs to be secured. So the next thing is prepare the tape. It takes a reasonable gripper because neither the parallel nor the 3-point gripper would really help to unroll the tape. So you need a suction cup, unroll the tape, so suction the free point of the tape, unroll it to a desired length, cut the tape. So it also comes to the conclusion that you can use the scissors to cut the tape, then secure it, and then in the end even do a quality check. So I think this gives you a first idea of where we are today. It's not even a look into the future. This is what we already have available today. These are models that are trained on all of the knowledge that the internet provides, plus some self-reflection. Self-reflection means it just tells itself it's what it is supposed to do and checks if it's reasonable, basically. And with that, we already get to a quite good plan, which a lot of people would not have thought is possible. And these are not multi-agents. This is one agent. Like, this is one system that does all of it. It does the planning. It does maybe the execution. We have a demonstrator. If anybody wants to know about it, Martin is the guy to come to. But we can already show this in action. And I think this is where we are really right at the border of having like useful toys to actually getting more into the direction of useful and actually good reasoning. And I think this was what in the last years was always missing, good old-fashioned AI, having classical symbolic AI combined with large models to have planning, to have reasoning, to have these capabilities. It's still not ideal. As I said, there are some things that are not good, and there is a publication that tests if this is actually multi-step planning and if you can do how many steps you can do pre-planning. But it's a quantum leap from what we had 3 weeks ago. Right? So this, I think it came out 2.5 weeks ago or around. So it's really a quantum leap from there. Back then, the models was just garbage what came out of it. You had to do all the self-reflection on its own. And so what I want you to imagine where this could go. Like, what could these agents, and this is one of the most famous agents, right? But what could these agents do in the future? Maybe we could have autonomous cities where you have agents that manage traffic, that manage public services, that even prevent things like mass panics. This you can already do today, actually, but if you have all of these agents that have very specialized things and they orchestrate each other, that work together in an orchestrated way, we can achieve really big things. Healthcare came up several times today already, maybe having really real-time health individually for everyone could be another thing. And then what we already have seen, collaborative creativity, right? A lot of you probably already do this. Use ChatGPT or DALL-E or whatever to give you some ideas, to give you some images, to just have a starting point, and then maybe even change little things. So you just say, okay, I want to change this, and then you get another proposal, and then you continue to do this. And I think this is really a way where we could co-evolve with systems like this and change the role that we have in discovery. But now the next interactive part. Another question, what would you want these agents to handle? I asked my son, he always tells me he wants an agent to clean his room. But let's see what you want. Ooh, it's very fast. I didn't expect any answers to be there. Chores, yes. Lab automation, routine tasks, organizational tasks, doing laundry. Okay, so classical housework, let's say. Cleaning, doing laundry, perfect. Care work is interesting. Boring stuff, great. I also want agents to do the boring stuff. Okay, but I mean, it goes in the direction that everybody's probably imagining. It's just like things that you don't really want to do, right? You have to do, but you don't really want to do them. So you would like to have somebody else to do this, but it's an interesting view into how I see it. Thank you so much. Then let's continue with the idea of many little helpers. I said this is normally exclusive to managers, so there's the assistant to the regional manager, or where does this idea come from? It's not a new idea, it's a pretty old idea, but where you might have seen it is in ants, right? So insects that are not capable to do, like a single ant could not carry this, but in a system together, and if they work together and help each other and communicate, and this is what comes up now, right? So there is one leader ant. It's not like all just a swarm. Many people think it's basically swarm, but there are people like single ants that have more power in the group and that tell them where to go, and they use pheromones, they use different models. Like last year, Barbara talked about it, right? Like last year we had ant navigation from Barbara Webb. But this is where it comes from, right? You look at many little systems working together, doing things that a single system could not do, and you also already saw our ants. So this is where we tried this the first time. It's quite a long time ago. But the idea was also, can we build little agents that, if they work together and work together in a coordinated way, solve a more complex task and can handle things that they could not handle on their own if they would be alone. And yeah, I don't want to show the whole video. The first thing that you have already seen probably is software development, also an example that Martin generated for me, so it's great. But here the idea is, can you generate me a game of life? So you have an autonomous agent that has, let's say, sub-agents that can do things. And what you see is there's one, for example, that does research. So one agent actually browses the internet and searches the websites and says, okay, what is the best way to generate Conway's game of life? What is like best UI design? How do I do UI design? So it first gathers all this knowledge. And this is probably what a lot of people that are not that experienced in developing would also do, right? You would search the internet and say, okay, what should I use? Should I use Vue or should I use React as a front end? And this is also what you see here. So you see a really interesting behavior where you're browsing the web to do things. And then afterwards, of course, you also have to develop the system. And this is also a way of solving this that humans would do. So you create a structure, the files that you need, and then you create some code, and then you try to run it, and then it doesn't run, and then you do a loop, and then you try it out again. But this is an early example of how different specialized agents can work together and can orchestrate each other and solve more complex tasks. So a single agent, and I think everyone who tried out ChatGPT or GPT-4 realized this, at some point they just get confused. Right? If you have a system prompt that is pages long, at some point the agent just gets confused. They know, okay, what should I do now? And then you get weird answers, and then you have to give it borders and stuff like that. But if you specialize one agent and know how they talk to each other, you can achieve bigger things. And now I just want to give a bit of an outlook. Can AI be creative and actually discover new things? This was one of the questions in the beginning, and actually you gave a very positive answer. But often the opinion is no, cannot, because it can just look what is in the past, and it can just do regression between the points or connect past points. But if we ask ourselves, what are we doing every day? It's mostly that, right? We build up on knowledge that we have, like physics, programming, mathematics, and then we connect these dots and we create something new. So I browsed the web yesterday and I just searched for some things that are already happening or that already happened. So 2023, AI created, for example, new drugs, but also new proteins. You all know protein folding, stuff like that. New materials. So Google, mainly DeepMind, used AI to generate a lot of new materials, new molecules that were not discovered before to be stable. Also research, so discovers new drawings in the desert, discovers things that I think nobody knew. So at least I was not aware of it, that not every fingerprint is unique, but if you have just availability of resources and you can use all of this data that is existing, you can create things that are connections of existing things, but still new things. Right? It doesn't need to be something that nobody ever thought of, but these are things that nobody ever thought of. So to just finish, maybe another question. I will I hope you still have the link. Yeah, I want to go there. The next thing is, what would you? This is I already did. Can AI be creative? We had it in the beginning, but the next question is this: like, what decisions would you trust an AI to take? And this is where I also want to end. I want to end with some more controversial questions. And what does this actually mean for us as autonomous people, humans? Like, how are we taking our decisions? How have we been taking our decisions? I think you have to skip this one answer before and then maybe reload. But I'm running a bit out of time, so I will look at this a bit later and just come to my last points. I think one point that I wanted to make is AI is already doing a lot of things. So maybe, I hope most of you are aware, but AI is already doing a lot of things. And now we are there and we can maybe connect them. So we have all of these single agents and we can connect them. And I want to leave you with these, let's say, a bit ethical and society considerations, just to get your juices flowing and get you to think about it. If we rely maybe too much on agents, what would happen to our own sense of control, right? Like, would we just let everything happen and say, they will do the right thing, and then maybe end up as people in chairs like in WALL-E? Do we want that? But also on the other side, could they maybe have biases? Could they be manipulated for harmful purposes? So these are all just questions. As I said, I'm on a very high level, so the following talk will give you much more insight. But I want you to also think about this. I said it before. What does this actually mean for human autonomy? Right? So if we have a world where we have a lot of personal agents and we trust them with more and more decision making, what does it mean for us? Okay, and then where can we go from here? My last two slides. I think we are at a point where we have agents, or we have the capability to build more and more intelligent agents, and it's not the first time that people say this, right? But it's the first time that actually it's evolving very quickly. So since the 70s, 60s, people are trying to build intelligent agents that do stuff. But we can already today use it to boost our knowledge, right? We have personal trainers. We can have, like, tailored to your knowledge, we can have teaching programs. Maybe they will become more active partners. And I think this will definitely change the nature of our work, but also the nature of our education. I think it's not anymore about retrieving the right knowledge, because this is an agent doing, but to interact with knowledge. Right? Like, up until 2 years ago, we basically lived in the time where it was important to query Google the right way and find the right knowledge and then retrieve the right knowledge. I think now this changed, because the knowledge is at the hand of everybody very easily, but you have to learn how to interact with it, how to ask the real questions, and how to interact with this knowledge. And so I come to my conclusion. Autonomous agents have the potential to transform everything from very mundane tasks that we have seen in the questions to very complex problems. The field is evolving extremely rapidly. I think everybody sees this. We already today see a lot of copilots. Some of them are bullshit, others actually work. So there is this like overhype where this agent does everything for you versus actually productivity and working. And if you want to learn more about it, stick around to the next talk. We'll give more insights and a concrete example of what we at Festo have been doing here. But now I'm having a bit time for questions. Thank you so much.
Thanks, Jan. Yeah, very impressive. I guess we are running a little bit out of time, so just one question, if there is one. No question. Yeah.
There's one. Sharam, great.
So maybe one question, because we see this fast improvement of current LLMs and all those. Do you think this multi-agent or this aspect to have a lot of little agent at some point also will disappear automatically because there is a big agent which can do all of them at once? We don't need any more this small agent.
I mean, this is an active question, of course. My personal opinion is I think it makes more sense to use things that we have and use specialized agents and like maybe planning engines and reasoning capabilities that we already have because they are formally right? So why would you train a big agent to do things that we already know that are formally right? Also laws of nature and so things that we just know. Why would we train somebody on data using that? So we should add this. But I'm not sure. I mean, GPT-4o1 is also kind of a multi-agent system in terms of interacting with itself. Right? So it's just reflecting on itself. If it could reflect with somebody else, I personally think at the moment this is more likely to be steering in the direction of solving tasks because you have specialized knowledge. But I don't know. Maybe it will be one large model solving everything in the future.